Finding the zeros of a polynomial function. In this video, we'll show how a graphing app and polynomial division is helpful when finding all the zeros of a polynomial function. So here's our example. F of t equals t cubed minus 3t squared minus 15t plus 125. To find those zeros, we know we want to set the function equal to 0. From there, we'll try to factor the polynomial and use the zero product property to try to find the zeros. Now, to factor the polynomial, we can use a couple of strategies. We could factor out a GCF, but because this one has 4 terms, we could also factor by grouping, if possible. If this is not possible, we can use technology, graphing calculator or some graphing app, to graph the function and see if there is at least one real zero. Then we can use polynomial division to rewrite the polynomial. We can factor any remaining expression or use the quadratic formula. So this is going to be our plan for solving this problem. So remember, our first thought was to factor the polynomial. We could take out a greatest common factor. That is not possible. We can factor by grouping, however, that is also not possible. Therefore, we will use something like a graphing calculator or Desmos.com to graph the given polynomial function, which we will represent as f of x equals x cubed minus 3x squared minus 15x plus 125. So when we graph it, the picture looks like this. We can see that there is one real zero at x equals -5. The fundamental theorem of algebra tells us that a polynomial function of degree 3, like this one is, has 3 roots. Therefore, there must be 2 complex roots. So the real zero, we remember, is at -5. We're going to use polynomial, long, or synthetic division to divide the polynomial by t plus 5. And we'll remind you what the process looks like here. Because we get a remainder of 0, we know that the original function can be rewritten in factored form as t plus 5 times t squared minus 8t plus 25. Now, this expression we're going to set equal to 0, but we can see that we should probably factor that trinomial if possible. It's not possible, therefore we're going to need to use the quadratic formula to find the roots. And remember, it's -b, right, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Now we can simplify under the radical. We know the square root of 36 is 6, and the square root of -1 is I. We can divide each term by 2, and our 2 complex roots are 4 plus 3i and 4 minus 3i. Remember, we have another root at t equals -5. So to go back to the original problem, finding all the zeros of this polynomial function, we have 3 zeros. -5, 4 plus 3i, and 4 minus 3i.